Hello everybody. Now that we have our fidget spinner drawn up, we're going to go through how to create our tool paths so that we can machine this out on our CNC mills. So the first thing we are going to do is we're going to start out by importing our tool libraries. We're going to create our tool paths, and then finally we will we'll learn how to export our G code. So let's get started. The first thing we need to do is get our tool library for our different tools and tool paths that we're going to be doing. If we go to the class website, on our 3D modeling page, we can download our RFHS tool library right here. So when we click on that, it will come up with a tools.json file, and we'll just download that. I already have ours downloaded. So on here we go to our manage, we click on tool library, and I already have my tool library brought in here. If you do not, what we can do is we can right click on local, we can click on import libraries, and then what you do is you go through and you look where you downloaded your tool libraries. I downloaded mine into downloads, so I have a couple other things in there, but we can see right here this is our RFHS tool library.tools. So then we click open and it'll import in there. And what you see is a whole bunch of tools that have already been created for you, as well as their tool numbers, which is super important for later on. So after you have that, you can hit close and we can get started. Now, this is just a model. So the computer doesn't know exactly where we're going to be running our tool paths because it doesn't know how big of a piece of material that we're going to be cutting it out of. So when we did our 3D printing, that was additive manufacturing. Now with our CNC milling and turning, that is subtractive manufacturing. So we'll be taking and cutting material away to be able to come up with our part. So to start up, we go to our setup and we click on new setup. And for this, our operation is going to be a milling operation. Our orientation is we want to select our z-axis and our x-axis. So on this, our part is going to be laying flat. Let's bring it this way. Our part's going to be laying flat in the mill sideways. So this is going to be our x-axis, this is going to be our z-axis, so that's going to be our top, and our y-axis is going to be moving back and forth like that. So what I did is I select my z-axis or plane and my x-axis. For my z-axis, I want to select a vertical line, and you'll notice that our z-axis is now going up and down. What we need to do yet is we still need to rotate this. So I'm going to select my x-axis, and I can select one of these horizontal lines right there. So now we can see that we have our z and our x in the right area. I want, that looks good right there. I'm having a difficult time getting this orientated in the right direction, but we want our y going that way and our x going the long way. All right. The next thing that we are going to do is, for our origin, we are going to select a stock box point. I'll click on that. And for my box point, I'm going to select the top left corner. So what we're going to do is, in our mill, we're going to have our part in there, and I'm going to take my hammer, my zeroing tool, and I'm going to zero off my y, my x, and my z. And that is going to be my 0. So just like what we had with our plasma cutter, coming to the right, that's positive in our x, going up in y, that's our positive y, and going up in z is going to be our positive z. The next thing we want to do is we want to select the size of our stock. So we are going to do a fixed size box. Our width, or our x, is going to be 2.95. Our depth is going to be 1.5, and our height is going to be 0.5. we want to have everything in the center except for our Z. We're going to change that offset from our top, and we are going to come down 0.02. So it's going to be 0.02 from the top. And we'll press OK. So the first thing we want to do is we want to take off the very top of this material, right? So to be able to do that, we come on over to our 2D toolpaths and we come down to face. And this is just a toolpath that will just barely take off the material on the top. So from here we're going to select Tool, and the tool that we're going to be using is Tool 3. If you don't have anything there when you first come in, we click on RFHS Tool Library and we select Tool 3 and press Select. For our spindle speed on this, we're going to go 8,000 RPM, and our feed rates is going to be 40 inches a minute. For our geometry, we just leave that. What it's going to do is it's going to take, this is the size of our stock, and it's just going to face down till that very top. For our heights, I'm going to go to my stock top for everything, and then my bottom height. So we can see that from my stock top, I'm going to be, I zeroed off my stock top, so I'm going to be going up off of there. And for my bottom height, I'm going to go to my model top, my stock where I zeroed from, and I'm going to go down to the very top of my model. For my passes, this looks pretty good. We're not going to need multiple depths for this one. And all of that looks good. Press OK. And we get a little preview of our path where it's able to go back and forth like that. If we'd like to actually preview what our toolpath is going to look like, we can right click on that facing toolpath and we come on down to simulate, and there's a little play button. Oop, that was a little fast. Back it up. We can speed it up a little bit faster, and you can see that it's going to go through and take off the very face. Now, before we can go on to anything else, we need to close our simulation or exit our simulation, so we'll click that button right there. And the next thing that we want to do is we want to create a 2D adaptive. So whenever we're doing this 2.5D machining, we always want a face. We're going to be doing a 3D adaptive for our roughing strategy, and then we'll come back and we'll come with a finishing toolpath just to be able to clean up that outside contour or inside contour or whatever we're doing. So the next step I want to do is I want to select my 3D, and it's going to be an adaptive clearing toolpath. And for this one, we're going to leave our 3/8 inch flat end mill. Our spindle speed is fine at 8,000 RPM with 40 inches a minute. I'm going to come to our geometry, and for our stock contours, what we want to do is we want to face the outside there, or we want to do a contour around there. Notice that I'm not selecting the bottom of our chamfer. I'm selecting the outside profile of that. So we're going to be doing the outside one as well as this inside right here. Notice we're not selecting these. These two ends here will require smaller bits, so we'll have to do a bit change halfway through. I just selected the outside here and the inside of our hole right there. For our heights, again, we go, for this, now that we faced it, we can go to our model top for everything. The stock top is just for when we face it. And for our bottom height, we can go to our model bottom. And the offset, or sorry, not model bottom, we're going to go to, yes, the model bottom. What I'm going to do is I'm going to do an offset of negative 0.02. So what that's going to do is it's going to go down further than the bottom of this, so that when we come back on our second operation, I'm able to just completely face off that backside and we don't have to do any of this contour machining. For my passes, my optimal load I want to change that from 150 thou to 15 thou. Stock to leave, my radial stock to leave, I want to leave 5 thousandths. And my axial stock to leave, I want to go all the way down. So I'm going to be doing 0 for my axial stock to leave. What that means is radial stock is I'm going to leave 5 thousandths of an inch of material before I hit the side. Axial is on the bottom. So our axial, we're not going to leave anything. We want to cut all the way down. And linking, that all looks good. So we'll press OK. And it may take a second for it to start up. And there we have our 3D adaptive. If we want to run a simulation on that, we will simulate that. And I can speed it up. It's going to go around, cut everything out, and do the inside there. The next step that we need to do is create our 2D contour toolpath around this entire thing. So we need to exit our simulation, go to 2D, 2D contour, and just verify that I still have tool 3, my 3/8 inch mill bit. Our spindle speed and cutting feed rate looks to be good. Go over to our geometry, and we want to select this outside edge right there. Make sure that we're not doing this bottom edge, but we want to select this outside edge right there. So after we do that, we'll go over to our heights, and we're going to go to model top for everything. And for our bottom height, we're going to go to model bottom, and I'm going to do an offset of -0.02. For our passes, our finished root feed rate, we'll put that down to 15 inches a minute. Take a nice easy pass on that. We'll press OK. And so it'll come around just like that. The next thing that we want to do is we want to bore out this hole so that we have a place that we can indicate off of on the other side for our OP2 when we flip this over. So what I want to do is I want to go to 2D, and I'm going to come down to bore and keep our same feeds and speeds for right there. For our geometry, I'm going to select the inside face here. For my heights, we'll go model top, and for our bottom height, what we want to do is we want to go to our stock bottom, and I'm going to do an offset again of -0.02 for that, because we want to have our mill bit go all the way through the bottom of our part. And we'll see that in just a little bit. So that looks good for our passes. Linking's good. If I simulate this, we'll slow it down a little bit. So it's going to do somewhat of a sort of drilling tool path. It's not a drill. You're going to be cutting through all the way, and we can see that it comes all the way through the bottom, so that when we indicate the other side, we'll be able to do so. So we'll exit that simulation. The last step we have 2 more steps. We want to clear out these with our 1/8 inch mill bit, and then we are going to run a chamfer on the top side of that. So just like before, we start out with an adaptive, and then we clean it up with a contour. So I'm going to go to 3D adaptive clearing, but instead of our 3/8 inch mill bit, our 3/8 inch mill bit's not going to be able to fit in there. What I'm going to do is I'm going to go in and I'm going to select tool 5, which is an 1/8 inch mill bit. We hit select, and we're going to run a spindle speed of 4,000 RPM, cutting feed rate of 20,000 for that. The geometry that we're going to be doing is we want to select the bottom there and the bottom there. Our heights, again, model top for everything. And then for our bottom height, we're going to go to our model bottom, offset of -0.02. Our passes, our optimal load, we want to really shrink down our optimal load, so we're going to go 7 thou for that one. Maximum roughing step down, We'll go 0.5 for that one, so we'll take it full cut. Stock to leave the radial, we want to do 0.005. Our axial, just like before, we're going to leave it at 0. And all of that looks good. We'll press OK. And it generates, and we will see that we have where it'll go down and it'll rough it out. However, we do have 5/1000ths of an inch on the outside there. So the next thing, we're going to go back to 2D. We're going to go to 2D contour, select the inside there, select the inside there. Again, model top for everything. Except for this bottom one, we're going to go model bottom, and then a negative 0.02. Passes, that looks good. We're not going to leave anything. All that looks good. We'll press OK. And that's just going to bring in that 1/8 inch mill bit and clean that up. The last thing we want to do is we want to put a chamfer around this part. So what I'm going to do is I'm going to go back to my 2D. I'm going to create a 2D contour. I'm going to change my tool from tool 5 to tool 23. You might have to scroll down a little bit for that one. Our tool 23 is actually a 1/4 inch chamfer bit. So we'll select that one. We can just use our default spindle speeds. The geometry, what we want to do is we want to select this top edge. Do not select this bottom edge. We want to select this top edge on all of our pockets and chamfers and everything like that. And we go over to our heights, and we are going to go model top for everything. So when we do our chamfers, we do model top for everything. And then what we want to do is we want to do a chamfer tip offset of 0.05. And what that'll do is that'll drop the tip of your bit down so that you don't run the tip of your bit right along that. If you do run the tip of your bit on there, what will wind up happening is you'll dull your bit a little bit quicker. So when we're done with that, we press OK. And we have our mill bit that's able to run all along there. Once you have all of your tool paths for OP1 finished, what we want to do is we want to post-process this. So to do that, we right-click on our setup. We will select post-process, which is right here. And we want to double-check that we have Tormach Path Pilot in our post right there. If you don't have that, what we can do is we can select the folder, and we come down to our Tormach Path Pilot. Now everything's in alphabetical order, so I'm just going to come down to our Tormach Path Pilot, hit select, and then what I want to do is I click on the drop down, choose another location, and I'm going to bring it into my local, select folder, and then copy to my posts. And then you should be able to see that right there. So for our output folder, what we want to do is we want to save this onto your folder. So I'll just go into my documents, which will be right there. And then the last thing we want to do is we just want to click post, and it will be successful when you see this little file or this little window pop up right here. So that is how we create our tool paths for our OP1. What we can do is we can go over to the mill and mill out OP1, or what we can do is we can continue on to creating our tool paths for OP2.